We have a blue light. Welcome to the November 2nd, 2023 CADXA meeting. I'm John N7NWL. I'm president of the organization. That means that everything is my fault. We don't have audio out here. I'm getting over from a cold, so I can send it in CW much better than I can talk, but not quite as quickly. We're going to do introductions and things like that. So since I'm starting, I'm John N7NWL.
I'm Virgil, K7VZ.
Bob, K7BHM.
Bob, NA7RH.
Richard, N7NT.
Dan, K9DR.
Steve, N7TX.
Steve, K7SP.
Norm, N9AV.
Walt, NJHG.
Dave, N7RK.
Patrick, WD9EWK.
Larry, W07R.
Lee, KY7M.
Ned AA7A.
Paul, B0ZRD.
Greg, KG7AZ.
Ron, WA0KDS.
Thomas, November Echo 7 X-ray.
I'm John, KA7CVJ.
Reinhardt, K7RGG.
Jim, KC1BB.
Mike, N7NMW. Mugwump.
Good turnout. This is one of the larger meetings that we've had. We also need to do the introductions from our Zoom folks. So Zoom folks, if you would take care of it, introducing yourselves, please.
Rick, W0RIC, good evening.
Mike, K7ING.
Wes, N7WS. In Tucson.
Israel, K7NO.
K5XI.
John, K7WP.
That's all of them. So welcome to the meeting, everybody. Other than the presentation, hopefully it's going to be a fairly short business meeting because I know they're really exciting. And we've wrapped up a whole lot of stuff this year. So hopefully this month and next month, we're going to taper off. Program time, EME. Next slide, if you would, please, Virgil. We actually are trained professionals. There we go. Introduction, Ned Stearns, AA7A. None of us know him. He's been a ham forever, done a lot of DX stuff, been on the cutting edge of a whole lot of things. Loves EME. It's a lifelong adventure. And the picture, go big or go home. Ned, you've got it.
So give them a test again.
Hello, testing. 1, 2. You hear me?
That's good down here.
Okay. All right. Yeah, I wanted to check for DX down there in Tucson, make sure it worked. So the reason that it appealed to me is because it was literally the hardest thing to do in the hobby. It just took resources that were to the max, and that just always attracted me. So, hello. Here we go. There we go. Okay, it's working. All right. You know, we all realize moon bounce is hard, and giving a presentation on moon bounce is harder. So what is EME? EME is simply the art of using the moon as a passive reflector to get signals to go further than as far as you can see. You know, if you're down the canyon and you can yell and you hear your voice reflected off the far wall, it's kind of cool. For us, the moon is probably the most the last thing we can use to rely on an echo to be heard on the Earth. Norm here asked me an interesting question a little bit ago. It explains a lot about Norm. He said, well, what if we had 2 moons? Okay, and I didn't really have a good answer for that, but it is a way of getting to make contacts further than line of sight or using terrestrial modes like meteor scatter and all the other stuff. So, but it requires an incredible amount of management of some very tough technical things. You need to have, big antennas, highly directive antennas, as much power as you can possibly muster, up to the legal limit, roughly. And you have to make sure you're not hampered by noise. I mean, it's a whole nother world is what is noise and how does it get into your system? And you also have to be lucky and avoid frequent visits from Murphy. And you're going to meet Murphy tonight. All right. So how do you accomplish an EME contact? I remember when I was a retired engineer, and one of my challenges was dealing with management. And engineers have lots of code words. We speak in a secret code so that management doesn't understand us. But every once in a while we have to talk to them, and they say, well, why doesn't this work? And you say, well, our output is 40 dB low. And they say, well, just go get some dBs. Get more. And I go, okay. Okay, so EME path loss, the amount of extinction of your signal as it gets to the moon and back is 260 of them dB things. Okay, so what does that really mean? 260 dB, that's a lot of dBs, but how hard is that? All right, imagine you take my signal and you chop it into a million pieces. You take one of those pieces and you chop that into a million pieces. And you take one of those pieces, chop that into a million pieces, one more, that into a million pieces. And finally, you got something that's 10,000 times still bigger than being 260 dB down. It's an amazing thing to think about, that you're trying to overcome all of that loss to make these contacts, but it's the only game in town. There's no other way to do it. So you have to be careful. Now, it doesn't always work. Something about HF, you get on HF and, at midnight, you're on 10 meters, nothing's happening. And then sunrise, and all of a sudden, boom, you get an enhancement. Okay, all of a sudden, signals are many, many, many dB higher than they were at midnight, because you have, reflective surfaces in the ionosphere and all kinds of good stuff happening. In moon bounce, all you have are extinction characteristics. There's as good as it gets is 260 dB down, and it gets worse from there. So you have to be patient, and you have to keep track of all those little things that can happen. I mean, there's the moon is not in a perfect circular orbit. It's got apogee perigee, and the difference is 2 or 3 dB, and that's something you got to keep in track. You want to make contacts when the moon is close. There's a thing in our world moon sandbox called the Van Allen belt. Okay, so I don't know how I got there. I don't know who put it there. Probably we all had too much spray on deodorant caused it. I don't know. But the Van Allen belt is it's a system of I guess it's fields that will alter signals as they propagate through that space. And there's a thing called Faraday rotation, where if a plane wave enters that Van Allen belt, it will, if it went in horizontal, it may come out the other end vertical, or somewhere in between. And so if you have a horizontally polarized antenna, you launch a signal to the moon, and as on its way through the Van Allen belt on the way out and on the way back, it may get rotated and be completely orthogonal to your antenna. So it's just another thing that gets in the way. Now, of course, we hams have gotten clever, and we now build antennas that have dual polarizations, and so we can transmit on either one and receive on either one or both, and in an effort to overcome one of these many little things. So that sort of stuff you got to do to make a contact. What modes? Traditionally, and the way it all started was CW. it was the kind of the ultimate accomplishment to copy CW signals on moon bounce, to the point where those who did moon bounce on CW prided themselves on the accomplishments, where a lot of the success was achieved by having the best skills at copying codes. I mean, it's hard to describe. I mean, you all have done CW, I know that, but on 40 meters, CWs have tone. Okay, on moon bounce, sometimes what you hear is the noise kind of keying on and off. Okay, so it's not, you're not copying code. You're sort of trying to determine if there's a pattern in what you're hearing in variations in the noise. I mean, it's really, really hard to do. And I did CW moon bounce for almost 14 years, and to the point where I worked everybody I possibly could with my station. But if I wanted to do more, I have to build even a bigger antenna system than I did. And I'll kind of walk through all the ones I did in my crazy career. Sideband is also possible. I have made 3 sideband contacts. One was kind of fun. It was a moon bounce weekend, and I had my station running, and Mike, KC7V, visited. And we were just chatting and, working on stuff in my radio room. And I look over at one of the chat rooms, and I see that the big station from Russia, I can't remember his call sign, some 2x2 Russian call. He was on with his 64 Yagi array. Okay. And so I said to Mike, listen to this. He put the headphones on, and he could hear sideband with a thick Russian accent that was coming from 2-meter moon bounce. And that was it. He was hooked. He from that day forward, he had the EME bug. And I understand it completely. I know how that happens. All right. And then lately, since 2004, there's been a migration to the digital modes, or there's been the introduction of the digital modes. Started with JT44, which is one of the first attempts by Joe Taylor to mechanize a signal coding scheme that would benefit from some processing gain available in the digital processing realm. And so JT44 was interesting, and it was sort of like playing anagrams. You would get, after each receiving interval, you get a bunch of letters, and they seem random. And the next one, you get a different set of numbers and letters. And after a while, you start to see a pattern, and you realize, I know who that is. That's this call, and I can use that letter, and then that number, and those 3 letters, and I got his call. So there was a lot of guesswork, and it was okay. It worked for a while, but then Joe came up with the JT65, which got rid of all that. You either got nothing or you got perfect copy. So it was really the big breakthrough was when he went to JT65, and now there's a new mode called Q65, which has been introduced for it picks up another couple of dB. And it also provides some improved performance on some of the higher bands where the effects of Doppler spreads your signal out quite a bit. Q65 helps put all that back together again and decodes signals that are spread quite well. And then there's a new tool out. It's called MAP65. It's actually been around a while, but what it does is it's sort of like this. One of the problems I have with moon bounce with CW, all right, it's time to listen to see if anybody's on the band. And so you grab that big knob in the middle, all right, and you spin it slowly until you hear something and you stop. And then you dwell and you go, okay, that's a birdie, all right, because there's no change in the tone. And then you go turn the knob a little bit more, and then you hear a signal finally that comes and goes, and you go, okay, this is CW. So I'm good. And you copy it and you move on, and you make a contact if you want to. But now that we're processing signals that are in the noise, when you grab that big knob, how do you know when to stop? All right. Is there a signal there or not? I don't know. Let me just dwell there for an hour and see if nobody was there. Let me go to the next. Okay. So it's hard to make contacts without coordination when you work modes which are at or below the noise level. The tool map 65 sort of says, well, let me take care of that. And it will process a chunk of the band where all the activity is, figure out who's there, and create like a band map. Like you're on using N1MM in a contest, you can say, oh, those are all the stations, those are the frequencies they're on. I've already worked him, I've already worked him, haven't worked him. And you just tune your radio to the frequency of the guy you haven't worked, and you wait, decode them on your system, and you make a contact. So map 65 sort of turns moon bounce into a format which is familiar to everybody who wants to work who's on the band. So it's kind of cool. So my life in moon bounces so far has lasted 40 years. And I went through a lot of phases. I being an engineer full of spit and vinegar, I jumped in and said, I'm going to build the best EME system you can possibly have. And it failed miserably, of course. I then took a break for a number of years and then got hooked again. And then I worked with a number of experts in the game and came up with a good middle of range system, got it on the air, started making lots of contacts. And then Joe Taylor came along and turned my antenna system into one of the world's largest stations on the air, because I picked up 16 dB of performance. It's like being a QRP station and going to a kilowatt. I mean, it's a dramatic change in the game for those with modest stations. And then I've gone on from there, building 2 monster arrays and going on expeditions and all kinds of stuff. So let me walk you through my EME life. All right, that first step. There I am, the thin young Ned Stearns. I again read an article in QST by Wayne Overbeck about the Quaggy. The Quaggy antenna is a hybrid antenna between a Yagi and a quad. It's got a quad driven element reflector and then simple Yagi dipole directors. And he had a design for a, I think it's a 13 element. I believe it's about 12-foot boom. And you can make the booms out of wood, and you can make the elements out of aluminum wire. And the quad loops are made out of copper, standard house wire. Very cheap, and it fit my budget. And so I built a 16 Yagi array. And being cheap, divorced, no budget, I couldn't afford connectors and coax, low loss coax. So I made my entire phasing harness out of ladder line, which is not recommended. Okay. Copper stretches, changes with temperature, and the only way to make it stable is to stretch it. Okay. So I went through this ritual. I mean, in a 16 Yagi array, there's lots of connections. When you get all of the connection points down to a single feed point, there's lots of pieces. I'm going to say 35 or 40. And so each one had to be cut, stretched, recut. And the spacers, I used Delrin rod that I drilled tiny little holes just big enough for the wire to go through. And, so millions and millions of pieces, millions of minutes on a drill press or out on my stretching table. Good therapy for recovering from a divorce. And I got the whole thing to work. With a friend of mine, with his help, we put it up. I was getting ready to operate in the ARRL contest, and the only part I was working was the receive side. And for me, it was like 20 meters. I just could not believe there were so many signals. I was having fun. And the next weekend of the contest, I was going to get on with the transmitter. And in that period of time between the 2 weekends, there was a monsoon-like storm that completely pretzeled the antenna array to the point where it had to be sacrificed. And that was okay because I was getting married anyway, and I had to move And so this whole idea was a flash in the pan. But it got me got my blood a pumping, and it's the first step in my journey. So for a number of years, after getting married and moving, I didn't really plan on a moon bounce antenna. I was having fun with other things. I had put up satellite antennas, got into Oscar 10, Oscar 13, but I kept building and building that satellite station over the course of time, to the point where I had a really good station at this one point. And a good friend of mine at work had gotten into moon bounce and was on the air regularly. And he said, well, why don't you try and work this one guy? He's got a really big signal, W5UN. And I went, okay. So I aimed the antenna and I called him and I worked him. And it was like that movie, The Fatal Glass of Beer. I was never the same. I used that station. It was a pair of I think it was 12 element Yagis, vertically polarized, which worked well for my satellite system. And I worked 20 stations off the moon with that setup, to the point where that was the last one I could work. And so I wanted more. And that's a common theme you'll hear a lot today. And so I got onto what's called the EME nets. Okay, that's an important thing that I think is missing today. Every Saturday and Sunday on 14.335 at 15 Zulu and 16 Zulu, there was the EME nets. First one was a 432 and above, and the second hour was 2 meters. And on 2 meters, the net control was VE7BQH Lionel. And check in, you have a roundtable quickly to just update what everybody's been working and doing. And then after that was done, it was sort of like an open session. And so you had opportunity to grab somebody and ask them a question that something that they have tackled successfully. And so you didn't have to go through all the pain and agony of finding out all the hundreds of ways to do it wrong. You could go to the guy who did that for you, and it will tell you how to do it right. And so I worked with everybody on that net for about a year to design this array, which is a 6 Yagi array. And I hand built all the antennas. Again, the phasing line, I was still cheap. I was still didn't have a budget for really high performance coax and connectors. I had to use CATV hardline and made my own connectors out of parts from Ace Hardware. But I got the entire array to work, and it was spectacular. I remember my first schedule. I was with some Italian, don't remember his call sign, doesn't matter. So 3 a.m, I get up, turn on the station, and his time to transmit, I'm listening. I don't hear anything. My turn to transmit. I send out the message, go back to receive, and I hear my echoes for the first time. And I said, well, screw this. I just sat there and listened to my echoes for an hour. Okay. It was just like, this is my own little radar. Yeah. The moon is right. Yeah. 2.7 seconds. Yeah. Look at that. Yeah. I mean, it was just an unbelievable sensation that I had an antenna good enough to do that and be able to hear my own echoes. And as time went on, I got again to another limit, about 450 stations I had worked, and I was running out of people I could work. And then along came Joe Taylor, who came up with JT 44 and then JT 65, and then boom, I took off again. And right now, my current tally is I have roughly 1,500 different stations that I've worked around the world on 2 meter moon bounce. And I always think of things in terms of, well, in my high school graduating class was 630 people. That was a big school, big class. I've worked 3 times as many people that are in my graduating class in high school, which is really kind of my measure, way of knowing how well. I've also worked, 900 VUCC grid squares. I've worked 168 countries, just incredible numbers of accomplishments of just using this station for 35 years. This antenna stayed up and, well, it was maintained for 35 years. I learned a lot about dissimilar metals. I learned lots about corrosion. Okay, when you walk up, your antenna's not working today, it doesn't turn. You walk up to a terminal block, right? What's a terminal block? It's got a screw and there's maybe some sort of a lug, and then there's maybe a place for the lug to land, and there's a wire going into the lug, right? So it doesn't work. You grab your voltmeter and you got volts on the wire, and you got no volts on the screw head or the lug. All right, and you go, all right, this ain't right. And so you can either tighten everything up again, fix it, or chop it off and build it again, or spray some goo into it, something. You try all kinds of crap, because that's just, when things sit outside for years and years, and here in Arizona, we got really very, very caustic soil, and you get rain, and it causes this cloud of fog, of salt that pastes everything. After that's all done, then out comes the sun, and it's 125 degrees, and all of a sudden all the chemistry goes to work, and you start, the metal changes its characteristics on the surface where you rely on all these connections to be made. So I learned a lot about, how to make things reliable. And I used to tell people at work, I worked on lots and lots and lots of different things, but I had an advantage over everybody else because I knew firsthand what can go wrong on stuff in the world, because I learned how to keep this antenna going for 35 years. It's just something you see, yep, I had that edge, that happened to me there, and the way around that is this over here. It's an incredible thing to have at your disposal, all this knowledge that you learn to keep something like this going. So one night I was just doodling on paper. And I thought, wow, I could fit a really, really big 6-meter antenna in my backyard if I made the antenna boom sort of out of rope. I could build almost the length of my backyard. I could make a long Yagi. So I went to work on EasyNet, came up with a design for a 10-element Yagi on 6 meters that I could rotate. If I had a support mast that allowed a little bit of pivoting, and then have 3 kind of support stands at the other end of the rope Yagi, I could have sort of 3 positions of this antenna and cover the swatch of the sky up to about 25 degrees of elevation, and capture, be able to get a signal aimed at the moon for, a part of every lunar day. And so I went to work, I built this thing, and by gum, it was a Christmas Eve. Again, heard my own echo. Of course, this time it was using the echo mode in JT65, and I managed to work 10 stations. In fact, one of my DXCC on 6 meters, I worked using this in Latvia, that I have not worked since on any other mode. All right, and it's kind of interesting at this time of the 6-meter craze. 6-meter permissions in Europe were a little weird. Okay, some countries permitted it, some didn't, because there was a channel 0 still in use in Europe, and as it was going away, in those countries where it went away, you could be on 6. Like Norway, you could be on 6 in this area here with 10 watts, in this area here with 20 watts. So you have very, very weird rules, and so Europeans did play moon bounce, but they didn't let anybody know, because everybody knows you need infinite power to do moon bounce, but you can work the world on F2. Okay, so they got on a work the world with a kilowatt transmitter, but wouldn't tell anybody that they were on moon bounce or worked you, because that would clearly indicate they were violating the rules. So it was a really strange time, but not a problem in Latvia. He didn't care. It was a UP2BAT, up to bat. All right, so later in my career, I joined the Voodoo contest group in 2005. I went to Mali with Mike and John and others, and Lee, Vince, the guys. And the second year of our stay in Mali, I proposed to the team that I could bring a small 2-meter moonbound station, and they didn't care. So Mike and I spent a little bit of time operating moon bounce before the contest, and then we hung around for a few days after the contest. I still remember Roger Western, G3SXW, came into the room when I was operating moon bounce one day before the contest. He sat down and he asked me a question. He says, "What kind of rates do you make on moon bounce?" And I went, "I've never heard rate and moon bounce in the same sentence before." I said, "But do you remember every contact you made on 20 meters this afternoon?" "No." He says, "Every contact I'm making, they're going to name their next born after me." So that's moon bounce. All right. So the next year we took our act to Guinea, and moving the pile of stuff from country to country. Is, you've heard the talks over the years. If you haven't, I'm sure you'll hear them again. But that's the ritual. We had this mountain of hardware, amps, antennas, coax, rope, rotors, radios, blah, that we would be in a pile in the country we were last in. Last year we were in Mali. So this year we're going to be in Guinea. So we fly to Guinea, and then we flew to Mali, rented a bus, and then threw all the junk into the bus, and then drove it to Mali. To Guinea. I'll get this right. And we would set up for the contest that year. So in the pile, at the second year of being in Mali, we had the previous single Yagi antenna system for the moon bounce project. And the time in between, I came up with this fixture that would hold that antenna and a second one like it, so I could get more antenna gain. I could stack a pair of these antennas. And so that was the objective of the second year we did this. And so we were also told by Roger, says, no more of this moon bounce stuff before the contest. It's taken up too much of your energy. You can set it up, but no operating. You can operate afterwards all you want. So Mike and I, we made our schedule so that we would stay 5 days after the contest and work moon bounce afterwards. But we would be by ourselves. Everybody else would have gone home. So we had all this help putting it up or getting it up, but we didn't run it until after the contest. So the day after the contest, moon was about to rise, getting all the wiring done. It was getting close, getting dark. And all of a sudden I realized, crap, it's not working. There's a problem. And the problem is up there 20 feet in the air. All right. And everybody has already left for England or Phoenix or wherever. And we were by ourselves. It was getting dark. And so we went to the hotel maintenance guy. Says, "Do you have a step ladder?" And he goes, "Well, I got this," which was 2 ladders that had some sort of mechanism to couple them at one end and a chain that prevented the bases from getting too far away from each other. And so we went, perfect. And so, and that got us about 10 foot high. So I climb up and I'm on the top of this thing, and it was just out of my reach. I couldn't get to the connector that was a problem. And so, so in the pile of stuff, there's something that anybody who's voodooed will know about. It's called the magic toolbox. Okay. Everything you need that broke could be fixed by something in that toolbox. Okay. It was just magic. I mean, everything that was in there was super. And so I went, I know how to get there. So I took the magic suitcase, put it on top of the ladder, and I climbed up the ladder on top of the suitcase in the dark. I couldn't see. It was black below me, black above me. And I swapped out the cable. It fixed the problem. We got on and we made 150 contacts. So death-defying act on that trip. All right, years later, Larry, W7R, who's here today, glad you're here, and I got to talking and say, hey, let's combine an expedition where you do moon bounce and he does some light HF work, and another fellow, Kenny, and K2KW, N2KW, he would do 6 meters. All right. So we all sort of met in Eleuthera in the Bahamas. And Larry and I assembled this antenna I developed, I actually had to get these antennas built from a custom antenna guy, and they had to be able to be knocked down to fit into a duffel bag. Okay, that was the objective. Everything in the entire array, the H-frame, the structure, all the antennas had to be able to break down into lengths of tubes that fit into 5-foot duffel bag, 4.5-foot duffel bag. And so we successfully got everything in there. I mean, we took a small little airplane from Miami out there. It was a small two-prop thing, but everything fit in. And we got it on site, built it, and it was a dream. We worked, I don't know, about 300 contacts on that. Larry had his magic moment where he got into moon bounce on this very same thing. I mean, it's a very, very infectious thing to get. And then in this trip, we had what we call the aha moment, where we decided to work on a future project together. I'll get to that in a minute. But over beer and pizza, good beer, not so good pizza, we came up with the aha moment for even further stuff. The next year, I decided, okay, I'm going to do this differently this time. I'm going to build a EME team, and I enlisted Terry and 6CW and Larry and we were going to all participate in moon bounce, and we're going to go to the island of Jamaica. And so, and the other thing we did is we tried to combine ham radio with a family vacation. So I would be in Jamaica for 2 weeks. My wife would be there the first week. She would take off, and I would stay behind and operate moon bounce in the second week. That was the plan. So everything came together. We checked in all our bags and all my pile of duffel bags. You used to be able to do that. They didn't count bags before. You just paid by weight or something like that. It's changed a lot since then, but it was about the last time you could do this. We get to Jamaica and we hit customs, and they were convinced that we were a professional filming crew. All right, he says, that's all film gear. I said, here's the lady who licensed me. Talk to her. It's one of your own people. She's the one that issued us the license. No, I'm sorry, you can't. You didn't fill out a carnet. You didn't get a customs agent. You didn't file your fees. You didn't do blah, 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 blah. And so all of our stuff went into bondage. And so that first weekend that was supposed to be a vacation, we spent in lines in administrative building after administrative building, first getting a tax number and then paying for a tax license, and then had to hire a customs agent who then had to fill all his paperwork. And then the important part, we had to hand him a bunch of money. And after a week's time, we finally got all of our stuff out of bondage. And my wife was very accommodating, amazingly. Didn't leave me then. And we got through it. And we got on here, and it was okay. I mean, the site was perfect. It was an unbelievable site. And Terry, N7 and 6CW had the contact of the expedition where, as the moon was setting, or it was just rising in HS0 in Thailand, and at the kind of a diving catch, they completed a QSO on that skimming shot, and it was just that affected Terry. He caught the moon bounce thing, and he's been bugging me ever since to get back on another reportable operation. But after that customs experience, I'm not doing that anymore. I can't do that. That was too hard. So I mentioned that aha moment that occurred in Eleuthera, Bahamas. What it was Larry said to me, says, after this expedition, why don't you take this system down to my place down in Maricopa, where I'm building a remote HF system. And I went, I got a better idea. All right, this is a toy. I have in my backyard a mountain of hardware for my real next antenna that I cannot fit in my own backyard, but you got a big backyard.
So why don't I build my antenna of my dreams in your backyard? And we operate it remotely. And I think a year and a half later, it lit for the first time. But it was an amazing exercise. Larry and I worked on, we broke the project up. I made all the hardware. He did all the controls and all of the, the publishing of information on the web and all that kind of stuff so that we could remotely observe the state of the system and control it. And I made all boxes that made things move and do their stuff, and made all the phasing harnesses and built again all the antennas. Lots and lots of work, but great therapy, good stuff. And when it got on the air, it was the antenna of our dreams. It was just it reached our expectations. We were a big signal on the band with JT65. We could work everybody, and remoting was okay. I had some issues getting into the network down in Larry's area. Is pretty skinny bandwidth site with lots of hops. I think we counted 35 hops or some crazy thing. And the likelihood of all of them being successful was low. So I would constantly time out, and it was just frustrating for me. But Larry had a few less hops, and it was just fine for him. And but it worked out. And of course, Jim, KC1BB, joined our team at that time. He was willing to jump in and do anything just to do something with ham radio. And we've since learned to become very, very good friends, and we share each other's experiences and our what skills we have. And we work on lots of projects together, and we've all the three of us have benefited greatly from that. When we actually started a project to have a VHF contest site down there, which we may get back to, but this was the centerpiece, and the 6-meter antenna we put up for Larry are just tremendous antennas that we had a lot of fun with. But then here's where Murphy jumped in big time. Okay, so I designed this antenna to survive 100-mile-an-hour winds. What I didn't design it for was buildings airborne in 100-mile-an-hour winds hitting the antenna. And that's sort of what happened. The back awning off of Larry's place got ripped off the ground, off any attachment to the house, scraped across the top of his house, through the array, and on another 1,000 feet downwind. And it kind of really destroyed his house. He had got a lot of water damage, a long time getting that all fixed. But the antennas were toast. I mean, the crossboom is an aluminum tower, and it's just not. It was just gone. All the Yagis were gone, everything. I mean, we've salvaged maybe one antenna out of all of that. And so with the help of insurance, we rebuilt. A lot of the infrastructure was good. I mean, the tower was good. The azimuth rotor was fine. The elevation rotor was easy to fix. But the whole H-frame and the Aggies had to be replaced. And so we went to a different design. We went to the longer Yagi. These are 28 element cross poles. And one attribute, I mean, it's almost the same gain, not quite, but almost. And yeah, but the good thing about it, it's a smaller profile, so it's harder for buildings to hit it. But there's a story beyond this I'm not going to get to just yet. Okay, so after all of that great success, I was a gentleman, Dave Huner, N7NR, who's a former member of this club. He used to live in Phoenix in the 80s, I think. And we remet at Visalia in, I think it was 2018. And he wanted to work with me on building a remote 6-meter moonbound station. And I thought, well, that's an interesting project. And the first thing I did is I reached out to Larry and Jim. I said, okay, we are still talking to each other after building a 2-meter EME system. What would you say about trying a 6-meter one? And it was mixed baggage. I mean, there was good ideas and not so good idea. We already had a great 6-meter antenna. We don't need another one. And it's just more work. And yeah, you're right. And so I went to my other group that I work with, the Top Band DX Club, that has the site down in Safford, further away. And I said, do you mind if I work on a project to put a 6-meter moonbound station out here? And nobody cared. And I worked with the Jensen family, and they didn't care. And I put it at a low profile, below sort of grade, so you really can't even see it. It's sort of invisible. And so I went to work with Larry writing checks and me designing and working with Hector to build it and test it and get it tuned. It went up and it was really good. It worked pretty well. SWR was not good. I stupidly relied on commercial power dividers and I tell you, those of us who are in the game know more about stuff than people who sell you stuff for the game. All right. And so what looked like a power divider to the guy who sold power dividers, it's fine, but it sucks. All right. And I can do better. I've done better. My arrays that I built everything for were spectacular. This was okay. But anyway, unfortunately, one of the things I didn't expect to have a problem with was the Azel rotor. What the Azel rotor, if for this original instance of this antenna, was what's called a sun slew drive. It's essentially it's like a worm drive turning the circular gear for azimuth, and then a similar pattern, pair in elevation, and it's all kind of bolted together. And they use these to drive solar arrays. And the vendor for this is a company in China, and it's pretty popular worldwide. And it was marketed by Green Heron, and there weren't too many people in the States who were using it. And but I picked up on it, and it met my needs. Unfortunately, the elevation motor drive lands on top of the azimuth drive and is held in place with 4, I'm going to say 1/2-inch bolts, but there was no thread locking gear and no anti-rotation, split nuts or split washers. So with the constant rocking of the array, it walked the bolts out, and the elevation drive with the array connected to it became disconnected from the azimuth drive, and it landed on the ground. And so once again, much like the Maricopa experience, I said, well, there's a lot here that's still working. All we need are new antennas, a new H-frame, and a new motor, and blah, blah, blah. So it's like the Jaws movie. We're going to need a bigger Azel motor. And so I went to the big brother of the 3-inch drive, to the 7-inch slew drive motor, which was an interesting experience. That motor weighs 150 pounds. And so to work on things, I had to invest in hydraulic hoists, hydraulic tables, and be very cautious about where I put anything, because gravity was a strong component of anything in the room with that 150-pound motor. So I managed to get everything rebuilt to the larger dimensions. I mean, like there's essentially the elevation drive is it's like having something that does a curl action. Okay, they're these slabs of aluminum. They're 1 inch thick, of 6065 T6, 36 inches long, 10 inches wide, with 12 holes in it for 3/4 inch bolts. I mean, this is an incredibly big thing. I mean, I'm sitting there with my old Craftsman drill press drilling, 1 inch holes in 1 inch thick aluminum. It's not for everybody. But I got through it. It went together. Hector gave me the thumbs up when we assembled it. He said, never seen anything like this before. And it is the best antenna that I've ever done in my life. Just today, this is fresh data. I don't use this just on moonbounce. It is the ultimate weapon on 6 meters. I've been on 6 meters for 50 some years. Okay. And I've lived here in the Valley on 6 meters for, I don't know, 50 years. And I know what you have been able to work with this thing. It's a whole different game. I mean, I am working a layer or two beyond what I've ever seen done before. Nobody I talked to has heard the things I've heard or worked the things I've worked. Okay, this morning I get up 8 o'clock. I get up. I have this ritual. I look at a site called DX Maps that has these red lines. Okay, these red lines are lines between endpoints of a contact that's posted on PSK Reporter or something like that. And it's always been, the red lines are always in the east. They always get all the propagation. No, they don't. Okay. We just don't know what you can work with this antenna. I was sitting there, I looked and I went, Northern Michigan, one guy, Northern Michigan worked somebody in the Mediterranean. Okay. F2, let me turn the antenna towards Europe. I did. I see, look at that 9H1. Okay. Let me call him. I've worked him 7 or 8 times already. All right. And he didn't come back to me, but I saw 3B8FA calling CQ. And I went, okay, this is cool. I give him a call. He comes right back to me. We complete. All right. That is the furthest contact I have ever made on 6 meters. You can only work 2 other entities and they're longer. It's almost like my old joke about Rodrigues is one of them. To get contacts any further than Rodrigues from here, you got to get on a spaceship. Okay. So it is at or near the antipode. Okay. If you get any further than that, it's getting closer. So it's what is that the things I can hear and see and do with that station are just are novel. Nobody's ever done this before. So here we are heading into a sunspot maximum with FT8 and my secret weapon. So here's the final step in my journey has been a project that my partner N7NR and I have started and been working with about a year and a half, which is a 2 meter moon bounce. He wanted to get on 2 meter EME, and that's cool. I don't want to do this in Safford. There's lots more technical stuff to deal with. And you need equipment, and I don't want to do it. Let me build it in my backyard. So we started this project, and I went with commercial cross Yagis. I rebuilt that drive motor that fell apart. It's the Azel for this system. It's big enough for this. Got commercial H-frame, high end. We paid for very, very strong, thick wall tubing for the entire H-frame, just because we didn't want to have, a weakness here. And I did all the phasing lines myself because we learned my experience. Don't buy anything from people who tell you they know what they're doing. They generally don't. And I have all the equipment necessary to make measurements of phasing harnesses. That's something I do well. I built the thing, I think I've given the talk about the Ned shed. That was the reason for the Ned shed, was to house the EME transmitters, receivers, and power supplies and all that junk. And I made the shed large enough to host another couple of racks for pretty much all my other HF systems. I got into my own amplifier. That went pretty well until I had a fault. And I finally figured out the source of the fault. What the fault was, it flashed over. And the reason it flashed over is because it was making way more power than I really wanted, because I had trouble with the control of the RF output out of the drive transmitter. And the reason I had that problem is because of an instability in the audio system that you have to plug into computers to run, digital waveforms. I could spend an hour and a half talking about the complexity of how do you get a computer generated audio to be exactly what you want and to work exactly the way you want it in WSJTX. It is really, it's kind of an open loop system. If it's not controlled or overshoots or whatever, your power goes as far up as you can imagine. And I went beyond the range, whole off voltage of the equipment for the power combiner in the amplifier, the Wilkinson T, and it flashed over. Everything's fine. I was feeling uncomfortable about it, and I've since worked with Larry on recycling his amplifier in our project. I'll get back to this because it has some features which I like. But anyway, it's been an interesting kind of adventure in the last year or so to work on a couple of new technology. I've never built solid state amplifiers before, and it was a real experience. So anyway, and kind of closing. In the course of my career, I've probably made 10,000 moon bounce contacts, which is, it's just something. I've made maybe 150,000 contacts overall. So a sizable fraction of my contacts that I've made have been on the moon. I've worked 170 countries now on 2 meters, and there's more coming. There's expeditions coming up. I'm back in the game. I'll be chasing them. These moonbound stations are when it's not time for EME, you can use them for lots of things on terrestrial paths. So they're wonderful stations. Learned an incredible amount of stuff, like I mentioned to you before, but my knowledge of metals and materials and strength of materials or lack thereof. I learned mostly from these projects. I've also had an opportunity to work with a large number of people to help me come up with some of these ideas and help me build them. And it's also kept me off the golf course, which I understand is another way to waste your life. But that's been my career, and I'm just getting started. There's more to come. I'm not done here. So thank you very much. Richard.
Two questions. That tripod array you had in the Bahamas, how stable was that?
KC7V has had an 7-element Yagi on a 20-foot mast in that tripod for 3 years now. Out of his place 2 years now, up in north of town. So it's a monster. It's very, very strong. Yes. I bought. Right. Yep. They are bulletproof, essentially. Yeah, Tom.
So 2 meters, what is your average RF power output? The second question, when you're hearing the station that you're talking to, what kind of S report are you getting? And the third question is, which transceiver are you using?
Oh, wow. Okay. First question, power. For a lot of years, with my 6 Yagi array, I ran an 8877 amplifier, and that was key down 1500 watts all the time. I built these signals are constant power. They're like FM. There's no AM component to it all. So it's kind of a constant power level. And so when doing 1500 watts out with 8877, again, I learned some things. One day I was on in a contest something, I was CQing away, and I heard a clunk. So I looked over at the amplifier and it wasn't making any power, and took the amp out of the rack, and the half of the plate tuning cap became unsoldered and fell to the bottom of the compartment. And so the eutectic there is what, 470F? And I went, fan's not big enough. Okay. So I had in the back of my shed the big fan, and it, again, it was about 100-pound fan, put it in a box, and I plumbed up the duct, the 5-inch duct work up to the bottom of the amplifier, turned on the fan, and the calendar blew off the corkboard across the room. And I went, got it, this is good. But I was using it for a while, and the fan stopped. And I went, oh crap, what's wrong? And is the fan overheated? So, well, I got to cool the fan. So, but wait, I got this blower that I took off the amp. So now I had the old blower cooling the fan that was cooling the amplifier. So this is moon bounce, okay, in a nutshell, is that this is what you got to do. Your next question was listening to signals. Okay, after I quit CW, I don't listen to signals. There's nothing to listen to. You can't hear the signals you're working. Yeah, it is below the noise level. Okay, I can copy with a JT65 jargon. I think it's around -15. You can hear 15, 16, something like that. Some CW people say they can copy down to 21. You can't. But we're making contacts down to 29 and 30. So it's 10 to 15 dB below what you can hear. So you really can't hear the signals. And what was the third question? What transceiver? Okay. At this time in that station right now, I have a TS2000. All right. And the reason is because I blew up my K3. When I was wiring it in, I got a cable cross-wired and I got 110 volts going to a digital input on the radio. And it's now an Elecraft right now, getting repaired. But I'm not done yet because I found a better combination using a Yaesu radio. I mean, I've got equipment now where I can measure the sensitivity within a quarter of a dB. I can measure how much site noise power I have because I can tell how much that I use what's called a SINAD measurement system. What it is, it's very, very repeatable measurement. And so I can determine how much sensitivity I lose. And what I do is I couple in I have a coupler between the antenna and my receiver, and I couple in a signal down 20 dB or something. I know the exact amount, and I can find very accurately at what point I get 12 dB SINAD. And so as I turn the antenna around, I notice that when I get to the horizon, I lose 5 dB of sensitivity, and I look over here, I get full sensitivity. So that tells me what's going on in the station. Without that, you just look at the screen. I don't copy anybody. What's going on? I mean, that's the problem with you don't have, it's like, oh, I hear signals on 20. Oh, they got that. It's polar flutter. So the K index supposed to be 5 or 6. With HF work, you tend to have auditory information that helps you figure out what's going on. But with EME, you just look at the screen. If you see nothing, did they stop transmitting? My antenna fall off? I've had the antennas fall off before. What exactly is going wrong? So having the ability to measure things is important. And the last question was, that was it, the radio. Yeah. So I'm not done. I'm going to keep working until I find the optimum system. And that's what's neat about having it in your backyard, not down in Stafford, is that I can experiment with things until I get it to be the way I really want it. Because that's the way it was in my house. I mean, I just continuously worked on it until I made it better and better. I ran a single W6 PQL pallet, which put out about 900 watts.
Ned, I have a question from Zoom.
Okay, Zoom.
Ned, this is Sid, K5XI. Could you say a little bit more about how effective your EME antenna array is on 6 meters at working terrestrial DX? Because I think that might get more people interested. The EME antennas proved to be real killers for terrestrial work, and I think you've worked D2 and some other stuff. Could you say a little bit more about how well your antennas perform on FT8?
You don't want to know. A week ago Sunday, using the Safford site, there was a light sporadic E to the south through Mexico where we linked into TEP, and there was this one sequence where I decoded 42 South American stations. Okay, at my site at home with an 8-element Yagi at 90 feet, I heard one. All right, it's not possible to even compare what's going on. A couple things about the reason I went to Safford is what limited experience I had with what is a strategically good place to be in this part of the world for working DX. I've always known that getting a path or a place where the path to Europe didn't go through the auroral zone was very important. And what that means is as south as possible and as east as possible. And Safford pretty much is that. And so that site strategically is good. It's the quietest place in the world. And, the antenna is one of the best in the world. So that combination makes it just a killer. Now, I have to fight. I've asked Darren Jensen, who's got a backhoe, I said, can you work on that hill, the Mount Graham over there? Can you, that's a 9-degree block. Okay. Pretty serious. So we don't hear too much out of the Pacific, but that's okay. I got this killer station in Phoenix that can. So really my strategy is not one station, but 2. All right. I operate where I watch 2 stations all the time, and I work whatever I can with whichever one has got the right thing going for it. So that's the real strategy, Sid, is not one, but two or three. Diversity is, this is where diversity, I like diversity in this context. So that's, it's just hard to explain. It's at 42-to-1 kind of thing is what it is. You just cannot compare what the two stations will hear.
So now you can answer the rate question.
The rate well, you still run them one every minute. You know, that's about tops. That's, well, with two stations, I guess I could work 2 a minute, but not likely.
There you go. Good job.
All right. Any other questions? Okay, everybody. Thanks a lot. We'll see you